Hello my dear students, once again welcome to your physics online class. Today we will be continuing with the chapter 2 of your physics, that is the laws of motion, and the part which I had missed out in the previous class was the graphical representation of a linear motion. So there are three graphical representation of the linear motion. That includes, the first one is the displacement and the time graph, the second is the velocity and the time graph, and the third is the acceleration and the time graph. So to begin with the displacement versus the time graph, okay, so the significance of this displacement and time graph is, using a displacement and time graph we can easily find the velocity of a body. So we'll consider the first case when the body is stationary. So what do I do? Here I see that the horizontal axis, that is the x-axis, it represents the time, and the vertical axis, that is the y-axis, here it represents the displacement. So suppose if I take a time as 0, 1 second, 2 seconds, 3, 4, 5, 6, 7 and so on, and the displacement 1 meter, 2 meter, 3 meter, 4, 5, 6, okay. So when the body is at rest, so no matter whatever the time may be, we know that the body does not move or it does not produce any displacement. So initially when you see the body, that sudden object was 2 meter away from you. As the time passes by, at 1 second the body will be at the same distance, 2 seconds at the same, 3 seconds same, 4 seconds same. So if I join this, if I draw a graph, so I'll get a line which is parallel to the x-axis. So this kind of graphical representation, it represents the body at rest, because yes, we see that even when the time passes, the displacement remains the same. So that means the body is at rest. Okay, so we can say that a graph where a graph of displacement and time, where the graph is parallel to the time axis, it means that the body is stationary. Now what if a body is in motion? So we know that when the body is in motion, it continuously changes its position with respect to the surrounding and as well as time. So here I consider a body at rest at time 0. It was at a distance 0 meter, that means it was very close to you, and as the time passes by, let the body starts moving away from you. So 1 second the body was 1 meter away, 2 seconds the body was at 2 meter away, 3 seconds the body was at 3 meter away from you, so and so on. So if you plot, you will get a straight line that passes through the origin. So this kind of graph, it represents that the body is in motion. So now whenever the body is in motion, we know that the body poses a velocity. Okay, so using this graph we can easily calculate the velocity of a body. So how do we calculate the velocity of the body? We drop a vertical line, suppose at any instant, suppose at say A, you are asked to find the velocity of the body. So what will you do? You will drop a horizontal line on the x-axis and a vertical line on the x-axis and the horizontal line on the y-axis. So knowing the slope of this graph, okay, so the slope is simply, it is the ratio of its x coordinate to the y coordinate. Okay, so slope here, suppose when I drop it, I get a value 6, and when I drop it to the time displacement axis, I get it the value 5, or say anything like 12. Okay, so in this case the slope is given by, it is the ratio of the y-axis divided by the x-axis. Okay, so I may simply write del y divided by del of x. So what can I do? So del x, the value of y here is 12 and the value of time is 6. So simply it is 2, gives 2 meter per second. So that is how we find the velocity of the body from the displacement and time graph. So using a displacement and time graph, we can easily calculate the velocity of an object. Now coming to the second one, the velocity versus the time. So what if a body is moving with a constant velocity? We know that when a body moves with a constant velocity, what happens? Its velocity remains the same. Suppose the body initially, the velocity was 2 meter per second. So when the time passes by, the velocity still remains the same. Okay, so 2 meter per second, 2 meter per second. So if I join all these dots, I'll again get a line that is parallel to the x-axis, that is the time axis. So this kind of graph, velocity versus time graph, when the graph is parallel to the x-axis, it represents a body moving with a uniform velocity. Okay. Now coming to the second one, when a body is moving with the increasing velocity, so what can we do? So we know that with the increasing velocity, with time the velocity also increases. So we get a graph passing through the origin and having a certain slope. So now using this velocity versus time graph, we can easily calculate two things. So there we could easily calculate the velocity. Okay, so using the displacement and the time graph, we can find the velocity of an object. And using a velocity and time graph, we get two things. The first one is the displacement, and the second one is we also get the acceleration. Okay, so now how to find the displacement and acceleration from the velocity and time graph is, to find the displacement you need to find the area covered by the graph. Suppose a body at certain instant, say at 6 seconds, okay, it has a velocity of I say 10 meter per second. Okay, so in this, if you are asked to find the distance or the displacement covered by the body, you will simply find the area covered by the graph. That means the area covered by the graph. Here I have a triangle. So to find the area, what we do, we simply use the formula. Area means it is half into base into height. So here the base represents the time axis and the height represents the velocity. So here the displacement will be simply half into what is the value of base, it is 6, into what is the height, height is 10. So 5, so 6 5 is 30 meters. So in that way, from the velocity and time graph, we can calculate the displacement. And the second one, to get the acceleration, we follow the same procedure. That means we find the slope of this graph. Okay, so simply the slope will be, it is the coordinate of y, that means the del y divided by the del x. So here it will be del y is 10 and it is divided by 6. So here 3, 5, or it will be 5 by 3 meter per second square. Okay, so using the velocity and time graph, we can calculate two things, that is the displacement and the acceleration. Now coming to the third kind of graph, that is the acceleration versus the time. So when a body is not accelerating, when a body has a zero acceleration, that means a body is moving with a uniform velocity. So in that case, the line will just overlap the time axis. It means that the value of the acceleration, here the acceleration is 0. So if you have a graph something like overlapping the time axis, it means that the body is not accelerating at all. Now when a body is moving with a constant acceleration, a line will be parallel to the x-axis. So suppose this AB, it represents the acceleration with a constant value. Okay, now when a body is retarding, that means a decreasing velocity. So in that case, we will have an axis to the negative of the y-axis. That means we will have at the lower portion. Okay, so in this case, if we have a graph which is parallel to the time axis and is below the x-axis, that means the time axis, you must be clear that the body is having a retardation. Okay, so these three topics was missing out, so which I have explained you here, and if you have still any problem, you are free to contact me in my WhatsApp number. Thank you.